Good morning, students. So today our lesson is network elements and network theorems. In that, first topic is two-port network. Okay. So here we should know the what is meant by two-port network. I will define two-port network. So port, what is meant by port? So actually this port is nothing but the pair of two wires, the pair of two terminals is called as a port. Okay na? If you take this diagram, this is a block diagram, one circuit, this is the input. Okay, so this is the one input, 1 dash. So here 2 dash is the output. Okay, so I1 is the current, input current. So V1 is a voltage between two terminals. So this is I2 is output current, V2 output voltage. Here I mean port, here what is meaning of port? Port is nothing but pair of two terminals or pair of two wires is called as a port. Okay, so here why we specified two port network. So here this is a one port, so 1 dash is the one port and 2 dash is the another port, 2 dash is the another port, so that it is called as a two port. I mean this network, so we know that the number of electrical systems, transistors, transformers, transmission lines. So we have we know that number of circuits or number of electrical circuits. Okay, so here this is a input circuit, input port. So this it is contain two ports. This is it is also called as a input port, input port, and so here it is called as a output. Here it is called as a output port. Okay, so why we call it input? I mean here we are applying current is entering through this terminal, so that it is called as input. We are giving supply current and voltage, so that it is called as a input. So here we collect the output. Here we collect the current, so that it is called as a output. So my main idea is, my main definition of port is, so this terminals, combination of terminals is called as a port. Okay, so here this contain input port and output port. I mean it contain two ports, so that it is called as a two port networks. Okay, just circuits, electrical circuits called as a, also called as a network. Okay, now so next one is what is the use? What is the use of this two port network? So for analysis of transistors, transmission lines, we use BJTs, we use this two port network. So these two port networks are classified into four categories. First one is the Z parameters. First one is the Z parameters. Okay, so first one is the Z parameters, and second one is the Y parameters. Next one Y parameters, Y parameters, and third one is the H parameters, H parameters. Third one is the H parameters, and fourth one is the ABCD parameters, ABCD parameters, ABCD parameters. Okay, so these are the four categories. Already we know that network elements, this unit contain two parts. First one is all theorems, Norton's theorem, Thevenin's theorem, maximum transfer theorem, reciprocal theorem. This is the second part of the first unit, all parameters, Z parameters. So this Z parameters also called as impedance parameters. It is also called as impedance parameters. So this Z parameters also called as impedance parameters. Next one is the Y parameters. Y parameters also called as admittance parameters. Admittance parameters. Okay, admittance parameters. And H parameters called as hybrid parameters. H means hybrid parameters. Next one is another parameters. So these parameters Z, either Z or Y, H parameters we will use for calculate the or analysis the circuits, so that we are using these all these parameters. This is a use of the parameters. Okay, if you take Z parameters, Y parameters, hybrid parameters or ABCD parameters, here we are using for analyze the circuit. For analysis purpose we are using these all these parameters. Okay, now first unit second part we contain only four topics: Z, Y, H hybrid parameters and ABCD parameters. First we will discuss hybrid Z parameters. First we will discuss Z parameters, that is also called as impedance parameters. Z parameters also called as impedance parameters. Here how we will calculate, how we will derive, we will see here. Very simple derivation. So one point is, one trick, I will tell one trick, that is, if you learn perfectly one's parameters, it is similar to that process is same to the remaining all parameters. Okay, so we have to learn to concentrate with the concentrate. First one is the Z parameters. First one is the Z parameters. Z parameters also called as the impedance parameters. Also called as the impedance parameters. Impedance parameters. Okay, so also called as the impedance parameters. Here we should know what is meant by impedance. Already we know that resistance we discussed so many times, lot of times we discussed about in resistance. So resistance is represented by R. Okay, so according to Ohm's law, V is equal to IR. At temperature constant, V is equal to IR. This is the Ohm's law. According to this formula, R is equal to V by I. R is equal to V by I. This is a resistance formula. Okay, by definition, the resistance, the opposing flow of current. Resistance is it is a one character, one property, it opposes the flow of current, so that this is called as a resistance. But that resistance in DC current, direct current. Okay, if you take the DC current, we use this resistance. Okay, if you take, we know that currents are two categories, DC current and AC current. Okay, so alternative currents, this is AC, alternative currents, so it has two directions, but DC has only one direction. Okay, so in DC current we use resistance term. So in AC current we use impedance, but property is same. Okay, resistance in DC current, it is similar property in AC current, nothing but the resistance opposed in AC currents, that resistance called as impedance. Okay, so impedance nothing but the resistance. This is also similar property of resistance. Okay, na? So resistance in DC current similarly. So this impedance nothing but, this is also resistance, it is in the AC current. So here it is called as a impedance. That is the definition of the impedance, the resistance in the AC currents. Okay, here we will derive the Z parameters. Very simple derivation. So already I draw this diagram. Okay, block diagram. So here this is the diagram of the Z parameters. So here I wrote I1 and V1. Okay, so I1 is the current, input current, current is entering, and V1 is the voltage difference between two terminals. I2 is the output current, V2 is the difference between two terminals, output terminals. Okay, one thing is, so here we are using some parameters V1, V2 and I1 and I2. Okay, these parameters are any circuit. I wrote here I1, I2, V1, V2. So in the case of Z parameters, V1 and V2 are the dependent parameters. V1 and V2 are the dependent parameters. I mean V1, V2 are the depends on the other parameters. Okay, so these are not independent, so these are the dependent parameters, and I1, I2 are the independent parameters. I1, I2 are the independent parameters. I mean these parameters does not depends any parameters. Okay, so that this is called as a independent parameters. In Z parameter, here we should remember, we should notice that one point, that is key point is, in Z parameters V1, V2 are the dependent parameters. Okay, dependent parameters. I1, I2 are the independent parameters. This is a key point in Z parameters. So if you take Y parameters or admittance parameters, in that I1, I2 are the dependent parameters in Y parameters. Next topic we will discuss later. So next, so here we should remember V1, V2 are the dependent parameters, I1, I2 are the independent parameters. Okay, so according to this circuit, so here I will write one formula. V1 is equal to Z11 and I1. Okay, so Z12, so I2, and next one is the V2. So Z21 I1 and Z22 I2. Okay, so according to circuit I write this formula V1 is equal to, so here when we observe this formula, V1 is depends upon I1 Z1, okay, different some parameters, so that these are called as the dependent parameters. Okay, but I1 R2 or the does not depend any parameter, so that I1 R2 is called as a independent parameters. Okay, so here we know that I1 I2 and V1 V2, but what about Z11 Z12? So Z11 and Z12, Z21 and Z22. So these four parameters nothing but properties, characteristics. These four characteristics called as the Z parameters. Okay, Z11, Z12, these are the some parameters. So these parameters called as the Z parameters. Okay, here we will calculate the value of these parameters. First one, if we take I2 is equal to 0, so when we substitute I2 in this equation, then we get V1 is equal to, so this term becomes 0, Z11 into I1. So from this formula, so Z11 is equal to V1 by I1. Okay, so this is the Z11 value. Okay, here when we observe here, already we know that resistance formula according to Ohm's law, V is equal to IR. Similarly, here resistance is equal to V by I. Okay, so here Z also, what is the formula of Z value? V by I. So here it is also resistance in AC current. Okay, similar property. So this is a DC current, this one is a AC current. When we observe these two formulas, R is equal to V by I, Z also V by I. Okay, na? So Z11 is equal to V1 by I1. So this we are giving the I1 is a input current and input voltage, so that it is called as a input impedance. Okay, this is called as a input impedance. So next when we substitute this I2 in second term, so V2 is equal to, this term becomes 0, V2 is equal to Z21 into I1. Okay, from this here we want the Z21 value V2 by I1. Okay, so this is a value formula for Z21. So Z21 is equal to V2 by I1. So this is called as a reverse transfer impedance.